Greetings. It's a short introduction video about ISDN, Integrated Services Digital Network. This video is made for the academic purpose. This presentation is compiled from the internet sources. Integrated Service Digital Network is nothing but ISDN. ISDN is nothing but a communication protocol, set of communication protocols which is enabling the simultaneous transmission of voice, video, data, and other network services. So, for multiple data services, ISDN is required. It's again a protocol which is enabling the data transmission, different types of data transmissions from one mobile network to another network. ISDN is primarily a circuit switched telephone network system, but it also provides the access to PSTN, packet switched networks. And we know that packet switched networks are used to transmit the digital signals like voice and data. It provides a packet switched connection for data in increments of 64 kilobits per second. The maximum of data transmission is 128 kbps. That is the maximum speed of the ISDN network in both upstream and downstream direction. There are two types of ISDN services: basic rate interface and primary interface. Basic rate interface or BRI is having two different channels. One is called as B channels or bearing channels. The another one is called termed as D channel or B channel or bearing channels. Another is called as D channels or um, signaling channels. D channels are used to transmit the control signals, whereas these B channels are called as nothing but voice bearers. It's voice and data, primarily the voice or any data which is used for communication is transferred. So, as we know that voice channels or the data channels should have the more bandwidth. So, the bandwidth of the B channels are 64 kbps, and the D channels are limited to 16 kbps. So totally there are two B channels in the basic rate. So 64 plus 64 kbps and one D channel. So it is a addition of another 16 kbps is used. In addition to all these things, operating overhead of 48 kbps is also used. So the digital pipe is of 192 kilobits per second width. The second type of channel is primary rate interface PRI. PRI is having is 23 B channels, bearer channels, voice bearer channels, and 64 kbps D channel. It is also having a separate data channel, but the width of the data channel is 64 kilobits. So totally, B channel is also having the same 64 kbps. Is totally 24 channels of 24 channels of each 64 kilobits per width. Sorry, kilobits per second. So this gives the total of 1536 kbps. In addition to this, 8 kbps is used for the overhead expenses. So totally 1544 kbps, 1.5 mbps is used. And the next thing is ISDN interface. As we have seen in the primary block diagram, all this ISDN networks are connected through the ISDN bridges. This this ISDN bridges are connected to the user equipments through the hub. So, ISDN interfaces are required to transfer the data from the ISDN networks to the all kind of ISDN bridges. So, there are two types of networks: narrowband and broadband. Broadband is initially important. Broadband is employing the fiber optic communication cables. Narrowband is used for the other common communication channels. According to CCIT, broadband ISDN is best described as a service requiring transmission channels capable of supporting the primary rate values 1.544 Mbps. The services, we have two services, BRR services and control services. BRR services is the telecommunication. In the telecommunications are referred to network services that enables the transfer data between two network endpoints. So, as shown in the figure, between two endpoints, this is user equipment, between the user equipment to another is in user equipment, that is within this network. PLMN is a LAN and mobile network. This possible transit network, all are the network elements. These are all the network elements within the network. The bearer services are equipped. Essentially, they provide the infrastructure and support needed to transport a video, voice, or any kind of data across the network. So this is bearer services form a crucial part of uh, fixed or mobile networks, as we know that it supports the various data transfer. The next service is teleservices. In the block diagram itself shown, the teleservices are between the terminal equipments or user equipments. A T is nothing but terminal equipment. Teleservices are a category of communication services in telecommunications that enable end users to send and transmit, receive the various informations or form of data, video, anything. So, two kind of ISDN services. One is called bearer services. Another is called teleservices. Bearer services are in between the network points, and teleservices are between the telecommunication end equipments. The other supplementary services are call forwarding, call waiting, caller ID and call blocking, conference calling, call bearing, voicemail. I mean, to explain all those things, it's all almost every one of us are using all these things. You can also directly write. This is the block diagram for the ISDN. ISDN subscriber is connected to the ISDN interface. ISDN interface, the switching between ISDN interfaces may be of any of this kind. It may be the circuit switching, packet switching, or common channel signaling. As we all know, common channel signaling is used for transmission of control signals. Other two, circuit and packet switchings, are used to transmit the data signals. From the ISDN services, again it is transferred to the ISDN subscriber. So, subscriber to subscriber is called as end to end signaling. So, the details of the block diagram is given here. ISDN subscriber is nothing but the end user. ISDN interface, we can have two type of interfaces, BRA or PRI. We know about circuit switching, data switching, and common channel signaling. The total connection between the two ISDN subscribers is known as end to end signaling. Working of ISDN. As we all know, it's basic call setup and call termination. So we start from the call setup and signaling. When the user initiates a call, D channel carries the control signals. D channel handles the signaling and call setup. Then the signaling messages establish a connection between the two user equipments. Once the connection is established, the B channels start to carry the data or voice, whatever it is, the data. B channels operate at 64 kbps, allowing the high quality transfer or data transfer. Call management and termination. During the call, the D channel continues to handle the signaling, managing call progress, and maintaining control over the B channels. When the call ends, the D channel signals uh, terminate the call and the channel is released for any other request. This is the call termination process. ISDN also supports call forwarding, call waiting, and other kind of services. The advantages are ISDN channels have the reliable connections. It uses only the ISDN interfaces. It facilitates the user with multiple digital signals. It has faster data rate, efficient use of bandwidth. We have also calculated the data rate as 1.544 Mbps for PRIs, primary interfaces. We improved call quality. It provides greater flexibility and all kind of integrated services. This ISDN is primarily introduced in GSM, then it is forwarded by or other kind of higher advanced networks, communications networks. Disadvantages are costlier. It's completely costlier compared to the other telephone systems. The PRIs are using the broadband ISDN. Broadband ISDNs are using the fiber optics. Establishment of fiber optical network is a little costlier compared to the conventional telephone networks. Right. Another thing is it requires a specialized digital devices. ISDN subscribers can only use this one. So ISDN requires the special digital devices. It's not flexible. The coverage is also less, high installation and maintenance cost, and limited features. For cost, it is very giving a limited amount of features. These are all the disadvantages of ISDN. With this, we are concluding the lecture on ISDN. It gives only the introductory part of ISDN. Thank you all.